stresses developed in cup drawing at different positions of the operation. Suppose for example, I want to produce a cup, right? So this is a sheet. Okay, this is a die. It will give a cup. This is die, sheet, punch, so here there are two zones, 1, 2, 3. First zone is called zone 1 or area below punch. So what are the stresses developed with blank holding force and without blank holding force? What is blank holding force here? Blank holding force is used to overcome whenever you apply a force on the sheet, the sheet on the flange portion, which is the third number shows, this will lift up, it will lift upwards. So to avoid the lifting of the sheet whenever you whenever you do drawing operation, to avoid the lifting of the sheet from the flange portion, we use blank holding force. External force is applied to hold the flange portion without not allowing it to lift out. If it lifts upwards, wrinkles will start forming. Once it forming into cup shape, the entire wrinkles will be formed. So this one, stresses induced in zone 1 without case A, without blank holding force, is if you are not giving any blank holding force on the flange portion and you are applying a load on the punch, then no stresses developed at region 1. With blank holding force, so this one is BHF. So with blank holding force, what will happen? You are applying load on with punch and you are holding the sheet, slightly, not with very hard force, slight force, with just to avoid lifting the sheet. With blank holding force, then slightly tensile stresses will develop. Case 2, zone 2, it is called deformation zone. In deformation zone, without blank holding force, there will be tensile stresses. There will be, because in there, that is the contact area where there will be tensile forces. Elongation takes place, so tensile forces. With blank holding force, also tensile stresses or tensile forces. Instead of force, stress is better, I think. Tensile stresses, remember. Next, zone 3, flange portion, that is called flange. Without blank holding force, there will be no stresses. With blank holding force, then both tensile and compressive stresses. Similarly, force required in drawing. We have studied that force required is equal to stress into area. Similarly, here we do in multiple draws. We won't get straight tall glass in one draw only. If you do in one draw, you need large force, because from big diameter to very small diameter you want to reduce. So instead of the step by step process we do, that's called draw ratio, number of draws, or step by step drawing. So your force required for first draw is pi, d1 is the final diameter, sigma y is yield stress, t is thickness of d by d1 minus c. So d is the initial diameter, and d1 is the diameter of first stage, diameter of cup after stage 1. So draw 1. T is thickness, sigma y is yield stress anyway. Similarly, F2 means pi d2. C equal to constant for a particular material to constant to cover friction and blank holding force. So this value of C varies from metal to metal. Similarly, work done, W1 equal to F1 into H1 So here how to decide the number of draws. So number of draws equal to capital D by final D, df, where df equal to final diameter. Then you will get a picture of how many number of draws you need to do that to complete the final to get the product shape, which desired shape. So defects in drawing, as we have discussed the drawing operation, defects in drawing. First one is wrinkling. As I told you that produce the wrinkles on the surface of the component. Wrinkles on surface of the sheet. It is eliminated by providing blank holding force. That is the wrinkling. Earring. Presence of wrinkles at the edges is called earring. Presence of wrinkles, not gills. Presence of wrinkles at edges. At edges of the sheet. So I produced a cup, but the circumference on the top of the cup is have small wrinkles. It is called earring defect. It's due to earring defect. Next topic is bending. Bending is one of the forming process where stress is applied is yield more than yield stress and less than ultimate stress. Bending is a forming process. So there are three types of bending: U bending, V bending, and edge bending. U bending. In U bending, you use a die of U shape. So this is U bending die. U shape die you use. In the same way, instead of curved surface of that, you use V shape. That is called V bending. In U bending, if you keep the sheet on the die, the total you need to prepare the sheet final component such that it has to touch entire the curvature. That's why it is surface contact will take place. But in V bending, in U bending, more force required. So the surface contact In V bending line contact, edge bending point contact. So the force required F U bending versus F V is to F edge equal to 4 is to 2 is to 1. This is about forces. And what about the length actual? Suppose initially it is of length L0, right? L0 is the initial length, and finally I got the shape of this is the shape of the component. T is thickness of the sheet. L0 equal to A plus B plus B. B equal to bend alliance due to curvature. So B equal to Rn into theta. Rn is neutral axis radius. B equal to R plus K into theta, where K equal to T by 3 if R is less than 2T, equal to T by 2 if R is greater than or equal to 2T. So substitute the formula, you will get the bending alliance. So this is more important also, bending alliance. Okay. Next, there are some other minor operations which we need to remember. Those operations are, first one is perforating. We may have seen sieve where there are a large number of holes of similar size. This is called sieve. This process is called perforating. Producing many number of small holes in the sheet is called. Next, notching. Removing a piece of material from the edges is called notching. So this is a notching, removing a piece of material. It is why we need to do is for accommodation of in lathe beds, and we use actually this one. Next is lancing. Producing incomplete hole. When you open coke tin, then you do incomplete hole. It is a combination of forming and cutting. Operations. Next one is nibbing. Producing a large hole using small punch. Large hole with small punch. Stretch forming. Elongating by between elongating the sheet by fitting it in between two fixed supports. So these are the few things, and we do 2-3 problems also along with question number 4. GATE 2008 1 mark question. In the deep drawing operation, blanks show a tendency to wrinkle up around the periphery. Answer is A. Buckling due to circumferential compression increase blank holding force. So the most likely cause and remedy of the phenomena is buckling is deep drawing cups tendency of wrinkles is a defect avoided by blank holding force. So A is the answer.